So you see, when we had discussed the short circuited stub problem, sorry, the short circuited transmission line. Okay, we have a transmission line Z0 characteristic impedance which is shorted at Z equal to 0. This is once again the Z axis. So this will be at what is the Z in at 0 minus. So we had seen that Z in at minus L, that is equal to JZ0 tan beta. Remember we derived this equation, and it's very easy if you put here ZL equal to 0, you will see this equation. Okay. Right? So we got first an open circuit, so short circuit at L equal to 0. There was a short circuit between it was inductive because Z in was positive at that was an open circuit. We had seen that, and between lambda by 4 greater than L greater than lesser than lambda by 2 was a capacitive load. Remember we had seen this in the first class, so in the previous classes. Let us verify this using the Smith chart. This was the short circuit point on the Smith chart. Actually, now this 7th experiment has some problems. If we take it towards generator, towards the load, they show the same thing. Take it towards generator, shows the same thing. So it's difficult to do this experiment here. So let me tell you at least something. So here it was the short circuit, okay, and lambda by 4 point is this one, because at lambda by 4 theta will be 2 times 2 pi by lambda by 4, that is pi. This will be my lambda by 4, beta would be 2 times 2 pi by lambda. Utshap, please mute. Equal to pi. And see that this is the open circuit point we had seen many times. So if you start from the short and move a distance of lambda by 2 towards the generator, then towards the generator, then we come to the open circuit. Can you verify the same thing what we got for from calculations? Obviously, this will be zero. This is 0. So we move to a open circuit. Here it is inductive. Okay. If we move further down, we go to the capacitive reactance part, and at Z equal to lambda, we come back to the open circuit. Remember? You remember? Is it okay? How we are moving? How the movement along the line is reflected on the Smith chart? Is it okay or not? Any questions you ask? This is where my load is. Okay, the short circuited load is. If we move,
Sir, please repeat the last part.
sure. My short circuited load is at Z equal to 0. Now we are moving. This is my short circuited load. This is at Z equal to 0. Okay. This is Z axis, positive Z axis. Now if you move in this direction, that is towards the generator. Generator is somewhere here. The generator is somewhere here. So we are moving towards the generator, towards the left. Okay. See here, wavelengths towards generator. The arrow is clear. So you have to move in the clockwise direction. So here it is 0 as expected. We come to the short circuit point. If we move in the clockwise direction along the Smith chart, we get inductive loads. At Z equal to lambda by 2, we come to this point, which is an open circuit. Okay. If we move further down, then it becomes a capacitive load. And finally, at lambda by 2, it is a short circuit once again. And if you remember that our curves was what we calculated from our actual calculation, it was like this. It was like this. Z equal to 0. Then this was Z equal to lambda by 4. This was again Z equal to lambda. So lambda by 2. Okay. So the same thing we are getting on the Smith chart. Is it okay or not? Is it fine? See that this is not linear. The increase is not linear. Tan curve is by no means linear. And see here, this increase is also not linear. So the entire thing, what we can get using calculation, the entire thing we can do using the Smith chart. Is it okay?
Sir,
Right? Now the seventh experiment, we will not do it on the virtual lab. We will do it here. Seventh experiment tells us find the unknown load impedance. Okay. So we take a load impedance of say, so we take a reflection coefficient. We are doing reflection coefficient 0.5 and angle is 0.5. So what they are saying, they have a load ZL. They have a load ZL which transfers into gamma, that is 0.5, and the angle is 45 degree. So here this point, is it okay? And the value of the load what they are getting, that is 2 plus j minus 2 minus j of this point. This is not. So this point is somewhere here. This point is here. Is it okay? The magnitude is
Sir,
0.5.
how did we get this point?
Gamma is given here. Magnitude and angle. Can you see? Can you
Yes,
see?
sir.
Okay. So we can locate the point using the magnitude and angle. This is 0.5 and this angle is 45 degree. So this will be somewhere here. Is it okay?
Yes, sir.
Okay. I do not have a scale, so it will not be perfect. So I can try whatever the scale. This is a 0.5 and this is 45 degree approximately. Obviously, it is not perfect because I am drawing it. So this point. Now this is the x value, and this circle will give you the r value. Is it okay? So we can find r and jx. Is this clear? How to convert the gamma to Z? Is this point clear?
Yes, sir.
Now, what they are telling us is to move by a wavelength of 0.4. So wavelength of 0.4, it becomes 0.4 lambda. Wavelength distance is wavelength. Okay. So this is 0.4 lambda. So this theta becomes 2 times 2 pi by lambda times 0.4 lambda. So this lambda gets cancelled. So this becomes 4 pi, 1.6 pi, getting the value 1.6 pi.
Yes, sir.
Okay. And 1.6 pi, if we convert it into degrees, that will give me 1. Pi is 180 degree. 1.6 pi will be 288 degrees. So 270 degrees plus something. So if this was my point on the Smith chart, once again I do it roughly. If this was my point here, say, so I draw a circle, constant gamma circle. It's a constant gamma circle, and we move 288 degrees in the clockwise direction. So that would be somewhere here, approximately somewhere here, and you get this point. Now you see the values of R and X at that point. That will be my Z. Is it okay? The problem with this is that irrespective of towards generator, towards load, it is moving in the anti-clockwise direction, which I do not think is correct. There is something wrong here. Like if I make it towards generator, it should move on the clockwise direction. It is not moving. Point 2, if I move here, it will move on the anti-clockwise. And the bad thing is that if I do the same again towards load, it is still moving in the same direction. So probably there is some problem with the seventh. Anyway, so there is a seventh experiment. Okay, any questions? You need to write how you have got the how to find the Z. That's what it is. Okay. Anything else? Next lab class we will do the Impedance Smith chart. Okay, and the next 2 days lab class we will start with that. Any questions? Any questions?
Sir, what are the screenshots we have to give for of simulation?
From this lab, from this from the small screenshots from this
For from 1 to 7.
1 to 7 days. Or you can give the screenshot of a Smith chart and you can manually draw using paint or whatever. No, because see, 1 to 5 will be one experiment, 6, 7 will be other experiment. Because we have done it in 2 days. Okay? One experiment, 1 to 5 will like this next Friday, and 6/7 the deadline is next week. Next week we will not perform an experiment. Next week there will be a theory, admittance with chart and how it works. The experiment will be done next week. And it will be about the stimulus capacity. Again, we will use the slip chart. Okay, then thank you.